Maybe it's the first hello world application. How did you write it? Yeah. What was it like? Fine. You have a main, right? Fine. So you have a main function there where you fine, and then you compile and execute. Okay. Fine. So you're supposed to write a main, and in that you write a printf. Fine. That's what we are doing. So fine. Java also, as far as application is concerned, an application in Java is nothing but a method called main. Okay. Fine. But for that, we have to write a Java file. Okay. So if I look at a Java file, so I have this Java file. Okay. A Java file has only 4 kinds of things. Okay. There are 4 things which go in a Java file. So entire Java, when you are developing Java, it's only about 4 things. Okay. A Java file is used for either defining a class. So you can define this. Okay. Fine. You may be defining an interface, or you may define an annotation, an enum. Yeah, you have enum, or you might define a annotation. So a Java file only contains these 4. So where is the main? Main is a method, right? So where do we write our Java application? Right? Methods belong to these kind of things. Right? These 4 things are there, and methods are part of these. So we don't straight away write a main. Okay, there's nothing which goes straight away into a Java file. When you start writing a Java file, you have to be writing one of those 4 things. It's just nothing else. There's nothing which goes in a Java file except for this. So entire Java is about, okay, how do I define a class? How do I define a interface? How do I define an enum? How do I define an annotation? And of course, using them. You define a class and you'll be using it in some other class. Fine. Fine, whatever you define, see all of these, whenever they are defined, they are going to be used somewhere. Fine, they will be used at different places within these 4 only. So class would be using other classes, interfaces, enums, annotations. Fine, so it's all about these 4 items and what goes inside these 4. Okay, fine, what goes in all of these 4 things. Fine, that's what Java is about. Fine, clear? So whole Java is only this. Entire Java is only about this. Okay, so fine. So if we have to write a main, yes, the application in Java is nothing but a method called main. Let me give the signature. That main would be inside those kind of items. We'll see where it can fit. Fine. Okay. The main which you are supposed to write is supposed to be a method, and that method is supposed to be a public. So a Java application is nothing but a method called main, which is public. Fine. Static. So these are nothing but modifiers for the method. You may write static public, public static would not matter. Fine. Now comes the method signature. The description of the method is the method's return type. The method would not be returning anything. Fine. So return type is void. Okay. Name of the method is main. And this method is supposed to take a parameter. And there's one parameter. The type for the parameter is a array of string. And you can say string array. The type is string array. You can give any parameter name. Example, I'll say A. Fine. So that's supposed to be a fine. And then yes, you'll have the body in which you can write the code for this. Okay, what you want to do in this. Okay, but this thing, this is what is an application. Okay, but this thing has to be inside one of those four things. Okay, fine. So let's see how we can go about writing a application file, writing a Java file. Let's see this. Okay, so let's say what we do is we'll say, oh, we want to have a Java file. Let's give the name as hello.java. So let's say we are creating a Java file called hello.java. Fine. So in this, we would like to define, let's say, let's go by defining a class. A very simple definition of, we'll see a simple definition of each of those four things. Fine. So very simple definition for a class would be, don't do anything, just say class. I want to define a class. So you'll need the keyword class. You can say class. Give a name to the class you want to define. And say, okay, I want to define class. Let me call this class as hello world. Fine, we'll just say class hello world, and you have the body of the class. Fine, we'll say class hello world and put the body of the class. Inside the body of the class, fine, you might have your application. You can include the application here. Fine, that application is public. Fine, we can have that static, return type being void, name of the method is main, parameter being a string array, a name for the parameter, and then the body of the method. Fine, an implementation for the method, which can look like, okay, we did a printf in C. Here, it's object oriented, so we'll have to deal with some object. Fine, you want to have a printf on the standard output. Fine, we have a standard output. Standard output is represented by System.out. System.out is an object. Okay, System.out is a object where you are interacting and saying, okay, on this, let me do a printf. So invoking a method printf. Okay, and here you could be saying hello world \n. Fine. Okay, and a semicolon, fine, to end the statement, and maybe that's it. Fine, so you have your first Java file. We give the name as hello.java. Okay, fine, and in this we are trying to include a class definition. Fine, a Java file can have only four things: a class, a interface, enum, or annotation. Okay, fine. So in this we are saying, okay, let's have a class, and the application which we are including it in a class. In this case, we are putting it inside a class definition. Okay, fine. Now, let's say once we have defined this Java file, okay, once this is, let's say you save this Java file, how do we compile this? So yes, if we use the command line, we have a command called javac, okay, and name of the file here is hello.java. Fine, we compile this Java file. What's going to be the output of this compilation? It's going to generate the Java bytecodes, and that will go in a file. The file will have extension of .class. So what file do you expect it to create? What's the name of the file? Extension is .class.
Hello.
You're expecting hello.class. The output here is it's hello world.class. You have defined a class called hello world. Fine.
Not throw any error because file name and class is
This will work.
that is what I normally heard.
Yeah. So that's what I'm trying to break. Okay. Fine. Yes, it's a good practice to have file name matching the class name. Fine. But not necessary. Okay, it's required in some cases. And it is a must when my class is a public class. If your class is a public class, yes, then what you say is fine. Fine. Suppose I want to have a public class. See, my requirement is I want to have classes. File is just a media for me to do what I want. And I'm creating this Java file. It's used as just some kind of a medium. It helps me to create what I want. What I want is I want certain classes. I want a class called hello world, but okay, I want it to be a public class. Fine, that's another requirement. So I want that this class should be public. If that's my requirement, okay, then I should start in a file called hello world.java. Fine. You decide on what classes you want.
This class is not public.
This is not a public. I didn't mention public, have I?
No.
No. So it's not a public class.
Oh.
Yeah. Why main method is static? Okay, we'll be coming to that static keyword later. Okay, and we'll be looking at static. But yes, you have methods in a class. You can have methods which will be static, and you may have methods which are non-static, and makes a lot of difference. Okay, quickly, if I want to tell you, it's like this. What are classes?
Sorry.
What are classes? Data types. These are supposed to be data types. That means you're supposed to have objects of this type. You're supposed to create objects and then start using them. Anything which is static in my class definition is not used on the object. I don't need to have an object of hello world in order to use this main. Okay, main can be used without creating object of the class. Fine, anything static is used without having the object. It doesn't relate to the object of where it is defined. Okay, that is the meaning of static. Fine.
So if this class hello world is public, then it will be accessible by anyone.
If it is public, yeah, it will be accessible by anyone. Now, again, that statement was true till Java 8. But from Java 9, oh, there's one more requirement. And there's slight change there in Java 9. Okay, there's a concept of a module. So it's within the module, yes, it's accessible by anyone within the module. But outside module, it depends on how the module is. It's a module which is supposed to specify that yes, it will be exporting these packages. Okay, we haven't seen packages and other things. Okay, so once we look at that, yes, then you'll get some idea. But yes, What you say, you can just take it that way. Right? So, okay, what do we understand when we say it's accessible by anyone? This class is accessible by anyone? What it would mean is, this is a data type which is available for use. Fine, which is available for use. But which members of this data type can then be used would be dependent on each member how it is declared. This member is declared to be a public. Okay, so you have a definition of a class, you have members within that class. Fine. And today we are not looking at the members of a class. Fine. Today we are not looking at that part. Okay, we're just trying to look at having some application. How do we compile? How do we run? Okay, fine. Application would be the method called main. Okay, we'll see how it works basically, how main actually gets started. Fine. So you can have a class like this. Now another thing what is brought to light is this. When you compiled hello.java, it created hello world.class because you have a class called hello world. By creating a class hello world, you actually creating a new type. Fine. You are using certain type like system, that's the name of a class. String here is name of a class, and these are class names. Fine. In Java, every type, what are types? Class is a type, interface is also a type, enums are types, annotations are types. Fine. Over and above whatever is built in. And you have int, long, all those things are there, right? There are built-in types, but these are also types. Okay, and for every type, like every class, interface, enum, and annotation, fine, we have a separate class file. There's always a separate class file for it. Since we have a string as a class, somewhere in the library, there is a string.class. Somewhere in the library, there is a system.class. Fine. Everything that you define has its own separate class file. Remember this. Types. And that's why you are actually only dealing with types. And it's all about types only. Fine. In a Java file, anything which you define, there are only 4 types of things which can be defined: a class, a interface, a enum, or a annotation. Anything you define, you will be giving a name to it. Okay, and when you compile successfully, there's a class file by that name. It's creating one more type, and every type has its own separate class file. Clear? And each class is dependent on or is using other classes. It's using other types also. Okay. In this case, yes, it's using the types which are in the library. They are part of the library.
So why are we using this string class within this main class?
Okay. This is supposed to be an application. We'll see what is an application. Fine. So first thing is, yes, when we compile, it's hello world.class. Fine, that is clear. Compilation, the output is hello world.class. Now when you want to execute the code, what do we want to execute? Application. Application is this. Application is supposed to be a method main. The name of the method is main, whose return type is word, which takes an input. It requires a string array. If this is to be used, it needs a string array. We'll see how that string array comes. Okay, and it is supposed to be declared as static. It should be static because it shouldn't require the object creation first. We don't want to be creating object first. Who will create the object? You have to start the application somewhere. So it has to be a static one, and it should be publicly available. Okay, fine. So this is what we do. And then how do we run this? So what is it that we want to execute? Oh, we want to execute this main. See, this class may have other things also. There might be other members, but one of the member is a method main. And our idea is to execute that method main. And in order to execute that, okay, so once we find there's a hello world dot class created, okay, it's like my class hello world is ready with me now. So in order to execute an application, we can use the command Java. Okay, and we'll just say the name of the class being hello world. And the name of the class is hello world. Fine. We have a concept of command line arguments. Fine. I give a command, I'll say Java. Fine. I want to invoke the main which is in hello world. But when I want to invoke this hello world, I might write a few strings out here. Fine. Maybe I don't write anything at all. Okay. I don't pass anything at all. Or you might be passing some arguments. When running from command, right? You can be giving some command line arguments. Okay, so what exactly happens is, let's see this. When you give this command, okay, what will be done? Look into this class definition. Does it have a main? All classes don't have a main. For example, that string, it won't have a main. System, they don't have main. Okay, but this one, oh, hello world, does it have a main? Because you are giving it to the Java command. So anything which you give to the Java command, this is supposed to have a main. It's expecting that there is a main. If there is a main, then to invoke main, I must have a string array. So what it does after it finds that there is a main, if there is a main, then let me create an array of string. It creates an array of string by looking at what is after the name of the class. Oh, there are 2 items here, so it creates an array with 2 elements. If there are 0 item, it creates an array with 0 elements. Array of size 0. Okay, oh, you didn't pass anything at all. Oh, there's an array with size 0. But it has to create an array, and then it invokes this method, gives that array to this method, and this method gets invoked. Fine, that string array is there for accepting the command line. It's my input. Whenever I write my method, I have inputs to that method, which are the parameters. Fine, return type is I'm not supposed to return any value. Yeah.
So if you don't mention it, then also the program will not execute.
Okay, fine. Now, if you don't mention anything, you're just writing a main. Okay, from compilation point of view, it compiles. Because what can go in a class? Oh, it can have a method. You can include other methods as well. In our example here, I'm just putting only the application, but there can be other members, which could be methods. Fine, there are other type of members other than methods also. Static method, non-static method. Name happens to be main, that's also fine. Fine. You might have, okay, so even if I don't mention static, and if I compile, oh, this will compile. Fine, it says that, okay, you want a method like this, okay, fine, I have this method. Fine, so compilation is fine, but when you use this command, Java and hello world, in that case, it's looking for that specific method. It's looking for a main which has parameter of type string array. If it doesn't have, it says, oh, this is not an application, I can't run this. Fine. Whatever class you are giving, if it doesn't have such a method, it's going to give an error. Fine. If I say Java and just say string, that's an error. And I don't find main inside the string. String array of string. It's not one string, it's an array of string. And that's what is expected, right? And so that's a application. That's right. That's a method signature for an application. Okay. Fine. So first Java application. Okay, simple thing. It's a printf in C. It's printf here, but on object system.out.printf. Okay, fine. Then let's say we extend further. Let's go further and say, okay, in the same Java file, and we continue in the same Java file, and we add a few more things. Okay, in a Java file, I can have a class definition. I can have one more class definition if I want. That one also can have its own main. The name can be anything other than hello world, because I already have one thing called hello world. Okay, you can have a class. You might even define an interface. Okay, so I'll say, okay, let me have an interface for the file. So I'll say, okay, in order to define an interface, we'll say interface. So this is continuing with the content. Okay, this is a comment and this is commented out. Okay. Fine, so we define an interface. Let's call it as hello interface. And in interface again, we can include an application.
Public setting.
Yes, you can put your public static void main with a string array. Give any parameter name. Fine. Normal convention is to use args as a name of the parameter. Anyway, it's not necessary. You can decide on using any parameter name. Okay, fine. Now coming to the string array.
What is the difference between class and interface?
Okay, there is a class, there's an interface, there's also an enum, and there's also a annotation. Okay, fine. Classes are more like structure. You have objects of a class. Fine. Interfaces are more used related to inheritance, and they are more from the inheritance point of view. And there will be super types. Fine. You have classes, and a super type for a class can be a class, or it can be interfaces also. Fine. Okay, fine. More of that would come later. Fine. Okay. Fine. We'll be seeing. Fine. We'll be going through classes. We'll be going through interface, and everything. Fine. Today, what I'm doing is I'm just giving you a syntax for creating the 4 kinds of items which can go in a Java file. So Java file is only about 4 things. That's one thing. Okay, a very simple thing. I'm not putting modifiers for the definition. What all modifiers can go here, what all modifiers go here. I'm not even taking what different kinds of members go in this. Okay, now just one more point. Here, I'm putting public static void main inside an interface, and this is something which is only allowed from Java 8. Prior to Java 8, if you try public static void main inside an interface, that would not compile. It would say, you can't have a static method inside a interface. Java 8 has allowed static methods inside an interface. And therefore, I can put my main here also. Fine. So conventionally, main method goes only inside a class. That's a convention. You can put it in a interface. And you can have it in your interface also. Okay, fine. Now let's do something here. Oh, someone may be passing command line arguments and I'm interested in using them. Fine. If command line arguments are passed, they are available through the parameter. I have this input parameter to receive all the command line arguments. Fine. So maybe let me put the variable name, let's say A only. Fine, I'll keep it simple. So you have a variable called A. The type is array of string. Fine, it's a string array. Okay, fine. Now what we have is for any array, fine, whenever an array is created in Java, it has a fixed number of elements. Okay, fine, it has fixed number of elements. And if I have A, which is of type array, right, it's an array type, you have A dot length to tell you how many elements are in that array. Okay, so here for example, I might first print, let's just do a printing. So you can say system.out print ln. Oh, instead of print f and putting a backslash n at the end. Okay, printf is much more than just printing one line. It is print formatted. Printf is print formatted. Fine. We have those. You can have multiple parameters there. In C language, if you have done that, then you could put your format string %d and all such things, and then pass more parameters. And that's how it is supposed to be. So a println is much simpler version of that. Fine. You don't do formatting. It's not allowing you to do formatting. You are supposed to pass only one parameter, not more than one. And whatever you give will be converted into a string. So in this case, let's say I'm saying println, and I'll say a dot length. And so let me print the number of parameters I have. How many command line arguments are given to me? And this will tell you after Java hello interface, and to execute this we will be saying Java hello interface, and then you pass some more parameters. And if you haven't done anything, this will say 0. Fine, you pass whatever the number of parameters you pass, that will be, those are the command line arguments. So it's just giving me the count of the command line arguments, and then maybe I'm interested in saying hello to all of those command line arguments. So you can write a for loop for int I equals 0, okay, I less than a dot length and I plus plus. Okay, and you might say, okay, let's have a system.out.println. Okay, and here I might just say hello, a space is included, plus a of I. So we have a string concatenation here. Fine, that plus is a string concatenation, string plus another string. A of I is a string. A is an array of string, and therefore AI is a string. Fine, have the end of the for loop. You can have end of the main, and you can have end of interface also. Fine. So I have a Java file which has a class definition as well as an interface definition. So hello.java contains class hello world with a main. It also contains interface hello interface with a main. Fine. And so how do we compile? Oh, we know how do we compile. Now if you compile like this, right, if you compile, what's the output? hello world dot class and hello interface dot class. There will be two class files. Every definition has its own class file. So there will be hello interface dot class also. Fine. Okay, like you define interface, let's see just the syntax for defining a enum. Fine. And the application, the main method can also be used inside a enum, but we won't be able to use a application, a static method inside a annotation. When we define annotation, no, annotation can't include a static method yet. Okay, fine. So main can be there inside a class, it can be there inside interface, it can also be included in a enum. Right?
It was also an enhancement for Java 8.
As far as enum is concerned, no, enums have come from Java 5. Enums with, as far as these types are concerned, Java 1.0 had only two things, class and interface. It started with class and interface alone. Okay, Java 5 added enums and annotations. Okay, Java 2 added the concept of nested types. Nesting means you are defining a class, members of a class were methods and some other things, but they said, okay, as a member, I can have another class inside a class. So nesting was allowed. Nested types. That's 1.2. Okay, so major changes, I'll say, fine. Some of the, fine. So it's like versions of Java, right? 1.2 was that way. And 1.5 added those two things, enums and annotations. 8 added the lambdas, and lot of features are there around lambda. It's mainly related to functional programming, right? Helps you think in terms of functional programming also. Fine. Okay, so let's see how enum is defined. Syntax is fine. So it's just very simple syntaxes. Okay, but what is an enum? What is an enum? It's a class. Yes, a class with which has got predefined objects. A class along with its objects, and there are no other objects which can be there. Right? It's just like a simple class which has its objects also along with the class definition. So it's more of a class definition only. But yes, the syntax wise, fine, the definition differs. So let's see this. So this is still the same Java file continuing. Okay, and I'll put it like this. We'll have to define an enum, we use the keyword enum. Let's call it as hello enum. Okay, now enums are supposed to have a list of objects first. The syntax of enum goes like this. In your enum definition, you first list down what objects you want and then give the definition. The class definition part comes in the second part. So there is a semicolon which separates the two parts. So I am saying I don't want any objects of hello enum. Okay, you have an enum that says, oh, there are no objects of this. So you straight away put a semicolon. My list is over. No objects. Fine. You could have put objects there. Fine. Okay. So just put some names separated by comma. Those many objects will be there. Each one is one object. have a semicolon, and here, what after semicolon? Public static void main. Okay. And some parameter name, let me call it B here. Fine, you can use any name. That's the only thing I'm trying to indicate. Fine. And you can put System.out println. You decide what you want to do here. Fine. And you have the enum.
So we have to put semicolon before the public.
Before, okay, this is indicating that list of objects is over. And now starts my definition part. The enum, the syntax of enum has first part is the list of objects, a semicolon, and then just like a class definition. The way you define a class, everything can then be there. So in the first part, I can't include a method. First part is about objects, object list. Okay. Okay, now defining a annotation. No, you expect a new keyword called annotation or anything? No, we don't have that. To define annotation, we use the keyword interface. Fine. It's used like this. We'll say @interface. Fine. Hello annotation. And yeah, maybe it's blank. I don't keep anything. I can't include a static method here. Fine, there are very few kind of things which can go. Here you can include certain type of method only. We have a concept of an abstract method. I don't want to go into that here. Okay, but yes, you could have a static method. Not static, but you could have a abstract method here. And there's supposed to be only abstract methods which are allowed here. Okay. Prior to Java 8, even interfaces as far as methods were concerned, it only allowed abstract methods. But from Java 8, it can have static methods. Fine. And that's why we can put our main method inside a interface. Okay. So when I compile this Java file hello.java, there will be 4 files. Output files will be 4. Fine, 1 for each of those things. Okay. And just a small idea of what is an annotation, right? Annotation is not like the usual data type. It's not like the data type which we'll say, okay, I want a variable of this type and start using it. Fine, create object and start using it. No. Annotations were created with a very different purpose. Okay. They are data types. You can always do that. Like, okay, you can declare a variable. In some application, you can declare a variable which is of type hello annotation. It's a type from that point of view. You can have a variable, fine, but you won't be saying, I want to create an object of this. Okay, there are different ways of using it. Fine, it's a type from that point of view, but yes, but the purpose is completely different here. Fine, I'll just give a small idea of what purpose it is. Okay, we have written the method main, right? We have written our classes. We write various kinds of elements go in my class definition. And we have concept of a method. When I say method, what is a method? A method is supposed to have what? A return type. A method is supposed to have a name. A method is supposed to have a parameter. That's a bare minimum. Then when we say public and we say static for a method, it's nothing but these are like something which tells about the method. It's just some kind of a attribute of the method. Oh, this method is a public method. Fine. Without a return type, no, there's no method. Without a parameter list, it may be blank. There's no method. And so that's a, you see, there is a definition of a method, and then you have modifiers for a method. And you have a modifier. A modifier like public is a modifier. Static is another kind of a modifier. And it tells something about the method. Oh, this method is a static method. Fine. But this thing like public, static, like this, whatever other modifiers are available for a method, these come from the language. These are coming from the Java language is saying them. Fine. These are keywords of the language. But suppose I want to say this method is a simple method. Oh, this method is a simple method. Why can't I say that when I write my code that this method is a simple method? Can I add some attribute which a programmer defines? I am annotating. You want to annotate something, fine? State something about a item. Just like you're saying, oh, this is a public method. Oh, this is a simple method. Why not? Simple is not something which is from the language. So you define an annotation. @interface simple. Fine. And when I declare when I define a method, okay, you won't be able to say directly simple since it's a programmer defined modifier. What is an annotation? It's a programmer defined modifier. Programmer defines those modifiers and starts using them. Okay.
How will Java understand that?
No, Java will not understand. The Java language will not understand them.
But you said that you will not add a static and that keywords.
So I was just giving an example that public and static are something which the language understands, but they are what? They are modifiers only. So I'll be able to say this is a simple method, but for whom? For whom? Not for the compiler. Compiler will only do a syntax checking that this is a valid annotation. Fine. Oh, how I will be able to use it? Let me change this. Let's say instead of hello annotation, I'll say simple. Okay. So I should be able to use here @simple. The annotations which are from the programmer are specified by saying @ and the name of the annotation. @simple. Okay, there are much more things than just saying. I've just taken an example as @simple, but it could be much more than this. It could be used for many more things. You could have attributes. Fine. For example, I'll say I have an interface annotation, not like simple, but maybe which says author. When I define my annotation for author, I might in this interface in this annotation, I might put a requirement that when you have author, you must give some value which is a string. Fine. You must give a value which is a string, and that can be done by saying putting a method in this whose return type is string. I am putting a method where the return type is string. Name of the method is value and should not have parameter. Here the methods, the requirement of annotation is, in annotation I can include what looks like a method to you normally, right? But no, they would not have a body. semicolon. The methods do not have any method here cannot have a parameter. That's one thing. They can't have parameters because they're just used as attributes for the annotation. They're just used to indicate that there is one attribute whose name, the name of the attribute is value, whose type is simple. So when if I'm supposed to use this, I'm supposed to use it by saying @author, fine. And since the value, the name value has a special meaning, it understands, fine. I can directly put a string here, giving the name of the author. Or I'm supposed to say value equal to this. And if I have some other thing, string, okay, I might have something like date. Okay, so author, fine, @author, value equals this, comma, date equals, and a string there. So it's a full system here. Fine. It's just, but only one thing here is, this is something which is done by these are created by programmer. Only thing what will be done by the compiler is to check whether you use it correctly or not. It doesn't derive any meaning out of it. It doesn't derive any meaning out of it. Public has a meaning. Static has a meaning for the language. But this annotation doesn't have a meaning. It's supposed to be used by some annotation processing tools. That means you should be writing your own tools separately which can analyze all this information. Okay, this guy has developed so many. So there is someone there's an author. I know this is an author, and he's developed so many codes. Or this author appears in so many places. So someone else will have to write a separate tool to know all that. Java language will not do anything. It's only going to do checking. But what is annotation? It's a modifier. Simple thing? Yes, it's a programmer defined modifier. And so a Java file has 4 things. So entire Java is only about 4 things. We just need to understand the 4 things. Fine.
We will have a practice on this later.
Yeah. This, you can define. Okay. I'll advise you, maybe you may have a blank annotation initially just to confirm with this. But yes, you can define like this. Fine. So you have a Java file with all these things. Okay, a few more things about the commands, the Java commands. Okay, another point here. Okay. Okay, we know how to write comments. And we know how to write comments. How do we write comments? There are 2 ways. Double slash means a single line comment. And we have a block comment, which is /* and can span over multiple lines. Fine. And */ to end that. Fine. Anything but. So that goes as a comment. Okay. Now just imagine there are so many things in this library. Fine. What you are defining some classes. That means you are creating new data types. You are creating data types so that they can be used by others. Fine, data types are supposed to be used by everyone. Okay, so you have your definition. You said, okay, this class, and you are defining all the various methods. So just defining a class and coming out with those so many classes will not make it useful unless you have a documentation. See, string class is there, and you would like to know, just declaring a variable string s equal to, and maybe declare a string, that's fine. But then on that s, what can I do? How will you know that? Would like to read the documentation about, when you expect someone to give a documentation saying, okay, on a string you have a method called length, on a string you have a method called char at, you have a so and so methods. You want that entire list of methods, what all things are possible to be done on a string and what they mean. When you need good some kind of a documentation which describes everything, some description for each of those methods. Fine. So same thing, when you define your class, people will expect that you have a documentation. So it's not just sufficient to create one hello.java. You're also supposed to write a documentation for what we have. Okay, so how do we do that documentation? Fine. The documentation should list everything, right? This file contains, this class contains these methods. At least whatever is usable, that should be. Whatever is not useful to others, maybe you don't list them. But if something is public, that means that's usable. So that must come out in my documentation.
So
yeah,
in one class that will be any public thing, right?
Yes, many things could be public.
So for each method, if we can write the documentation, we could have.
Yeah, so we'll have to prepare a documentation, not.
For each method?
For each method, we should, right? Otherwise, the other person will not know what it means.
So we have to document within the program itself, or we have to document
Okay, so what we have here is, we have a tool as part of JDK. Fine. Like we have used two commands. We have used a command javac for compilation. We have used the command java for executing the main. Okay, we have a command called java doc. Okay, this command, you give the Java file to it. Okay, so you'll say, okay, java doc, and okay, I'm just giving, currently I'm just saying hello.java. Okay, when I say java doc hello.java, what it will do? Look at the content of the Java file, okay, and identify what all things are defined here. So it will identify, oh, it has these 4 classes. And each class, what are the various public members in them? Oh, but one problem we have here is, our classes are not public. None of the member here is public, and therefore it will say, oh, I don't find anything public, so I don't create any documentation for you. There's no need of documenting anything, because you didn't create public things. Okay, so if things are not public inside, fine, and I still want documentation to be generated, okay, so for our case here, we'll use one switch, java doc, and you'll say minus package. Okay, fine. We'll see package thing later, but just take this as a command for your initial exercise. Okay, so your initial exercise would be hello.java, fine, with these 4 definitions. And when you try java doc, okay, with the minus package, you should be able to see a documentation. It will generate nice HTML documentation. And it will be generating a HTML documentation. So it will be, there will be so many files. One of those files which it will be generating will be index.html. Okay, so just open that index.html and you should be seeing the documentation. Okay, one thing about managing all these items. I have a Java file which I have written. I've got the class file generated by the compiler, and I have got all those HTML and GIF and whatever other things are there generated by Javadoc. Fine. I would like to have them organized properly into folders. Fine. We don't want them all the things in one place. I'm supposed to keep my source code here. I'm supposed to keep all my compiled code here, binary files, and I'm supposed to keep my documentation in a separate place. Fine. We would like to have them organized properly. Fine. So fine. So let me give these three commands again, how they may be used. Fine. There are a few switches which we'll be using. Okay. So let me try to put some kind of a directory structure where we'll use this and how we give these commands. Okay. So you may have a structure which looks like this. So you have some folder, and I'm assuming you have some folder. So we have one /home /java1. Okay. Here for our patch, I'll create one folder java1804. Okay. Fine. So you'll have such folder like this already where you'll be there. Right? When you log in, you'll be in this place. Okay. So in this, you create one folder for the source code. So this is my place. Fine. I would like to have one folder called src. So this is supposed to have all my Java files. So you'll keep the Java file here. Store the Java file hello.java may be here. Okay. You would like to have another folder called bin, which contains my compiler's output goes here. The output for compiler should go here. Okay. And then you would like to have a folder called docs. The output from Javadoc goes here. And that's how you'd like to organize them. Okay. So first thing, fine. You change your directory and be in the src folder. That's the first thing. Fine. So if you are logged in at some particular place, maybe your command could be cd src. And src is the place where you have saved your Java file. Okay, so that could be your first command. Okay, that's a prompt. So change directory src, and then you might give java c from src folder saying you have a switch called -d. -d for destination. Fine. My destination folder is ... /bin. Fine. ... bin go to the parent, and parent go to the bin. Okay, and then give the file name. So you are compiling hello.java like this. Okay, fine. So the class file which is generated would not be stored in src, it would go to bin folder. Fine. Okay. To execute the code now, you don't change the directory again and again each time. You stay in src only. Right? And then you can say Java. Now it won't find the class file here. Where is the class file? In the bin folder. Or from the current place, it is ... /bin. Fine. So you have an option of saying -cp. Stands for class path. the path from where classes may be loaded. The Java runtime is supposed to look for the class file and load them. Okay, so where all it should look for the class files. It's a a whole list of directories may be specified, number of paths may be specified. In our case here, we just have one path, that is /bin, and then you'll have hello world, something like this, or hello interface, or hello enum. Fine. Followed by, if you are passing command line arguments, you can pass command line arguments. Fine, but this is -cp for class path. Okay. And to generate the documentation, Java doc, again -d, okay, /docs -package, and you could be giving that hello.java. Okay, just remember one thing, be careful. Here we are not giving name of a file, we are giving name of a type. We are giving name of a type. We have defined a type, class, interface, or enum, which contains a main. Name of a type which contains a application. Fine. Not all class or interface or enum may have a main. Fine. So what you are supposed to give here is something which contains a main. Okay.
Docs, right?
/docs. The folder, that folder, docs folder. So dot means here, and in that docs. Yeah.
And dash package.
Space and -package. Yeah, minus. So -d /docs.
Package and then space.
Space and then whatever. You can be giving multiple Java files here. Space. Java files.
Same other class then, right?
No, other Java files. I have multiple Java files. I might even say star.java.
No, sir, if there are multiple files, then hello.java, either separately.
Hello.java space something else.java.
You can give.
Yes, you can give. You may even say star.java. They're in the same folder. And all of them. Or even with Java C, when you're compiling, you could be giving multiple Java files here. Compile all of these.
So what does CP means?
Okay, CP is for class path, the place from where classes are available. From where can I load the classes? Then, because I'm currently in SRC, I'm currently here, right? Where are my class files? They're here. They're not in my current folder. So I'm just saying, okay, when you want to load classes, the classes are available from bin. So that's -cp, class path, path for the classes. Where are the classes? Fine. It's not only one place. Fine. Let me explain another concept. Maybe what you have is, okay, now these classes. I was mentioning about what? Library classes, like string. There is a string.class. There will be something like a system.class. Now, if you search your entire directory, you won't come across string.class. But there is a string.class. Because what has been done is, it has been put into an archived file. The library classes are not just one, they're not just, there's so many of them. You won't find so many files to be there. What they have done is, okay, they've created, just like, we compress and keep files in one single file, like we have a zip file containing so many folders and files, right? So a similar thing can also be done for the Java classes. So the various library classes, they have been put into small compressed files like this. The extension is not zip, instead the extension is .jar. Fine. So we have a jar stands for Java archive. Fine. Java archive. So these are archive files. Okay. So if there are things, so what I'm trying to indicate here is you may include, maybe you are using some libraries, third-party libraries. Okay. So if you are using some third-party libraries, maybe you will organize them. You won't keep them in bin because they are not yours. Maybe you would like to keep one more folder called lib, where all my libraries I'm organizing. So I might have something .jar over here. Maybe let's say I have abc.jar over here. Okay. I have something like abc.jar over here. Okay. Even when I'm compiling, right? While I'm compiling at this point also, because what is going in hello.java uses something from abc.jar. Okay. There are classes which are in abc.jar which are useful to compiling hello.java. Whatever is the Java's library, like the string and system, they will always be available. But if there are third-party things and you are using them, the compiler needs to know about how they can be used. It will need to check their syntaxes, okay, whether they have been used correctly or not. Fine, and therefore those should be available. And so even with Java C, it's possible to use a -cp option. So when I say Java C -cp, and it is /lib/abc.jar, and when I'm executing -cp /bin, okay, I have my classes here, as well as I have some of my classes, I'll put a colon. If it's a Windows system, you'll be using a semicolon. Fine, and then I'll say, okay, /lib/abc.jar. So you could be specifying multiple locations from where classes may be loaded. You're specifying locations from where classes may be loaded. So if class, I'm only giving name of a class, hello world, but then it's supposed to load that. It has to locate where is it. So it will see, you mentioned a class path. If you don't mention -cp at all, it will only look in the current folder. It will look for the class file in the current folder. It won't find in src. Okay, so we're saying, okay, when you need classes, search for them in the bin. If you don't find there, then search for them in that lib. I have abc.jar. Okay, go inside and search there. Fine. So -cp, you can add to Java C also. Fine. To Java also. Fine. Indicating if classes are needed, they are available there. Fine. Load them from there. What I am using is available here, right? Okay, coming back to the Java doc thing. Yeah. Fine, when we use Java doc, the kind of output which is generated looks nice, that's fine, fine. But the way we have written so far, it will be just very plain thing, saying, okay, there's a class like this class contains a method with the method signature, but there's no description. There's no description for the method. There's no description for the class. There's no description for other members which are being shown in the documentation. The documentation, yes, formatting is very nicely done. Okay, but then there are no notes or any such things, right? No description about the members. Or you want to include that description for the members in the Java documentation. Okay, that can be done by including documentation comments in your Java code. So when you write your Java code, you can include documentation comments. Okay, so where is a documentation comment? Let me show it simple in whatever we have done. Okay, if you go back, okay, fine. Now documentation comment, that description, you want a description for the enum. And if you want a description for the enum, then put the description just before the definition of the enum in a documentation comment. A documentation comment is nothing but a special kind of a block comment slash star star slash double star. Put your description for the enum over here just before the enum definition and put a star slash to end it. So when the Java utility works, okay, it is going to say I have this enum. So wherever it says I have this enum, it will also pick up the documentation comment corresponding to this enum and include as a description for that enum. Same way, I want a documentation for the main method. I want some description for it. So just before this, include a, so even before any of the modifiers, okay, it has to be supposed to be before the modifiers. So even if there's an annotation, before the annotation, fine. Just before all the modifiers are there, you are supposed to put a documentation comment. So include a documentation comment, fine, so that it can then be picked up by the Java doc. So you may generate Java doc without the documentation comment, fine, or with the documentation comment. With the documentation comment, oh, you'll find all the descriptions being picked up from what you have written here. Fine, you'll have to try this to say this.
Yeah, what we normally do is we put the double slash and we put the small description that this class what it will do.
Those,
We never
see,
generated
these are the comments, the usual comments. We call them as implementation comments.
Yeah, right.
Those are the comments which may be used by the one who is looking at the code, who is going to maintain the code. But this documentation comment is for the user of the type, for the user of the class. It's from that point of view.
So if we put the
See, I'm writing a loop. Okay, see, I'm writing that loop statement, right? Now, above the loop statement, I'll put a description saying why I have done this, what I'm trying to achieve in this. And that's not supposed to be available for the documentation.
So the structure of the documentation will be the main class and then it will take all the...
Oh, you'll have to see it. I won't be able to describe it here. I can show you the kind of things from the doc, because there is, okay, the entire Java source code. Okay, when I say entire Java source code, I mean all the library classes, interfaces, enums and annotations, whatever is there, okay, they are all available. The source code for all that is available. Okay, and in that source code, they have done all this documentation also. Okay, so if you want to learn how to write documentation, you can look at their code also, as source code is available. Not only source code, from that source code, the documentation has already been generated and it's available. Okay, when you install JDK, you'll find src.zip, that's the source code. Okay, there's a separate download for documentation. Okay, so that's again another zip file. Fine. So if you download that zip file, yes, you should be able to see the documentation. I'll show you a documentation here. Fine, how it looks like for the library things. Okay. and it looks like this. Okay, initially when you generate documentation, you may not find three. There are three frames here, right? You can see you won't find three. You will find probably only two. Okay, there'll be one and there'll be one here. One giving the list of all the classes, all classes, interfaces, all that. Fine. This is for packages. We haven't currently created multiple packages. Okay, so unless we go for creating multiple packages, you won't find three. Fine, when you generate Java doc. But yeah, this is the Java doc for the library, Java's library. Okay, so okay, you want to see how it looks like? Maybe you want to see it for string. There's a package called java.lang. Yeah. Okay, so there are interfaces here, there are classes here. Fine, well, oh, this thing, fine, this what you're seeing here is all because of the documentation comments. This is because of documentation comments. Okay, let's try to see the source code. Okay, fine, how it matches all this description here. Fine. See, what happens is we get src.zip when you install JDK. What I have done is I have created a folder called src, and then within src I have actually extracted the zip file. Okay, so this is extraction of the zip file. So that's when we have package, you'll realize that we'll have to have folders like this. So Java, and within that lang, and here's the string. Okay. Yeah. You can see this description here, /. Okay, and here's the whole description. Fine. Yes, of course, they have used HTML in this because they know it's a HTML file. This comment will be included inside my HTML file. So they use this, and you can see how it corresponds to what you're seeing here. Fine. Fine, is this? That's what is this?
This is source code.
That's the source code. Any library file, okay, there is source code for that. Java file. And when you install JDK, you get it. src.zip is there. Just expand it, and you should be able to use it. Fine. Okay. Yeah. Fine. So, yeah. So now, any questions? It's like you have. So next is like next is about practice, but I think we can do it tomorrow. That's okay. Fine. So tomorrow I think we can have practicals. Fine. And